Hi, this is Carol Hobbs again. We're going to look at another problem. Again, this is 7th grade Common Core. And in this problem, they're talking about the area of a rectangle. And they tell us that the area is the product of its length times width. So when you hear the word product, they're referring to the arithmetic operation of multiplication. Sum is the answer you get when you add. Difference is the answer you get when you subtract. Product is the answer you get when you multiply, and quotient is the final answer as a result of division. So they're talking about the area of a rectangle, and the area is length times width. So area equals L times W. That means to multiply. And when you see two variables together, that also means that you're going to multiply. So that's the first information that they gave us. It's the product of the length times the width. Find all, and that's basically for a rectangle. For a rectangle. Area for a circle is different. The area for any other type of polygon. Now, polygon simply means, poly means many, and gon is side. So polygon is basically a many-sided figure. We start off with the triangle. That's our smallest polygon that becomes a closed shape. Then from there we have that, so that's 3 sides. Then from there we have our 4 sides, which is our quadrilaterals. That includes your rectangles, your squares, your trapezoids, your anything that's 4 sides. Then you have your pentagon, 5 sides, your hexagon, 6 sides, your septagon, 7 sides, your octagon, 8 sides, your nonagon, 9 sides, and decagon is 10 sides, okay? So we're talking about this, and they gave them they gave them a little table to complete. So it says find all whole number pairs of length and width that gives an area of 24 square meters. Record the pairs in the table. So they're looking for the multiples. Then once you multiply them together, the product, the answer as a result of multiplying would be would equal 24. So we have the length, we have the width. So in this table, think of all the multiples of 24. You have 1 times 24. So if the length is 1, the width would be 24. Because 1 times 24 is 24. Then we have 2 times 12. So the length is 2. The width is 12. Then we have 3 times 8, which is 24. Then we have 4 times 6. That's the last set of multiples for 24. So now that we have these, now we're really going to reverse it. Now 6 for the length, 4 for the width, 8 for the length, 3 for the width, 2 for the length, 12 for the width, and I've run out of space, but 20, I'm sorry, that should not be 2 and 12. See, I need my students, they always stop me and correct me. So then we have 12 for the length, 2 for the width, and then we're going to invert the first one. Our length would be 24 and our width 1. Those are all of the multiples for a rectangle, taking everything into consideration. And then from there we are to make a coordinate graph. So, excuse my lines, but we're going to make a coordinate graph of that. Recall what I just put up. The horizontal axis is your x-axis. The vertical axis is your y-axis. And we really do not need a negative. We're really basically operating in the first quadrant of the graph. This is the first quadrant. And here everything is positive. We did this before. Again, just a review, quick review. Second quadrant, x is negative, y is positive. In the third quadrant, both x and y are negative. And in the fourth quadrant, x is positive and y is negative. Notice they're opposites. They're opposites. Positive, positive, negative, negative. Diagonal. Negative, positive, positive, negative. So they are opposites. Well, you always want to have your graph somewhat in some type of order that helps. Let me move the x-axis down a little bit. So we have, that's 5, 10, 15, 20. All right, that takes us to 24. 5, 10, 15, 20, and I'm going to need a little bit more. Okay, our first one, remember x equals length in this case, and y would be the width. So when we graph this, we have 1 and 24, we had 2 and 12, we had 3 and 8, 4 and 6, and then we reversed that process. We had 6 and 4, 8 and 3, 12 and 2, 1, 12 and 2, 1 and 24. Or 24 and 1. Now, I'm going to connect the dots with a different color. So, this is not to scale. But now you see it's not linear. There's a curve. So this is a little curvilinear. So this is called curvilinear. Okay? So that's what the graph would look like. Now they ask you to make connections on your graph, if it makes sense to do so. Well, should we connect the points? It's always a good idea to connect the points because it gives you a better sense of what this graph is doing from left to right. We read a book from left to right, we read a graph from left to right. So notice, it starts way up here, then it drops substantially from 1 to 2. So there's a tremendous decrease. So that means the slope of this portion of the line is definitely dramatic. Okay, so then it continues down, and it's still continuing down, although the product is still 24. You multiply the two values, you still get 24. Then we are to describe the relationship between length and width for rectangles of area 24. Well, we know there's a rapid decrease, especially initially, from x equals 1, or the length equals 1, to the length equals 6. There's a rapid decrease. Then it slows up, it slows down. So remember, identify what your graph is doing. Talk about your graph as if it's a problem for you, not a problem on a piece of paper, but a problem for you. Thank you again for listening to Grandma, and enjoy. Bye-bye.